Here's the next example. Sketch y equals to 4 minus x times x plus 2 quantity squared times x minus 1 quantity squared. So how many roots does it have? It has 3 roots. How many are repeated? 2 of them are repeated twice because of the second degree. What degree polynomial is it? It's going to be a 5th degree polynomial. And is the leading coefficient negative or positive? It's going to be negative here. So let me work through that. So if I were to multiply this out, I would have minus x times x times x times x times x. So one negative in there makes it negative x to the 5th plus all the other stuff that we don't really care about. Alright, so minus x to the 5th. It's a 5th degree polynomial. Negative leading coefficient, so that means it kind of goes like this. And there are repeated roots. So let's see, roots are x equals to positive 4, negative 2, 1, and 1. So this time I wrote the roots in repeated fashion. There are 5 roots, 2 of them are repeated. Okay, you don't have to write it that way. This is more of a guide, and particularly in a teaching guide for me, but I think it's a good idea for you to write down the roots. Because the more information you have in front of your face, the less you have to store up here. Okay. And finally, the y-intercept, plug 0 in, we would get 4 times 2 squared times negative 1 squared. 1 times 4 is 16, positive 16. So there's 16, and my roots are at positive 4, minus 2, and positive 1. So the graph will pass through these 3 roots and that y-intercept. And it's like this. And finally, the repeated roots are where it behaves like a parabola. So at negative 2, it's repeated. It's going to come down and just touch. It's going to come down, just touch, go back up again, and then it's going to come down, and 1 is going to just touch. Ooh, that's pretty steep. You know, that's kind of hard to draw, right? Let me try to do a better job of drawing that. Actually, I think what happens, you know, the fact that these roots are equally spaced, no, it's not symmetrical. I thought it might be symmetrical, but I don't believe it's going to be. All right, so let me try that again. I think it's going to be more likely that it dips down, comes up, comes down through the y-intercept, and just touches, goes up for a while, then comes down through 4. Okay, so does that satisfy all the requirements? Well, there are 3 roots, and the repeated roots are at 1 and negative 2. That's where it behaves like a parabola close by there, at those 2 repeated roots. It does cross to the y-intercept, which is a positive number. Leading coefficient negative means it's going down to negative infinity on the right, and since it's 5th degree, it's rising to positive infinity on the left. So it is done. There is a good sketch, and that's what you do there. Now I should tell you, I'm likely to put on a test a problem where I describe all this information without giving you the exact function. All right, so I may give you all the information that you need without giving you the function itself. And that's how I get even with people who try to do this on graphing calculators. People doing graphing calculators do a terrible job because it takes a lot of work to get that right. And you know, you're not here to learn how to punch buttons on a calculator. You're here to learn how to think. And so that's why I will, you know, if I'm testing you, you'll likely get a problem where you won't see the function. I'll just tell you about it, okay? And then you take that information and sketch it out accurately. So anyway, that that completes this. And my book has a lot of examples in it, so I encourage you to work through those reinforcement problems and look through those and check yourself. And because I think my problems are a little more interesting than the ones in the course textbook, the regular textbook. In the course textbook, a lot of those functions cross to the origin. They have 0 as an x-intercept and y-intercept, as a root and a y-intercept. And to me, that's not quite as interesting as having a y-intercept that's negative or positive. So the problems, if you're my student, you're more likely to get the type of problems I'm talking about here. And so that's why I wanted to focus on those types in these videos and in my book. Not saying that the textbook problems are not good. They are very good. And you should practice those as well, especially if you need more practice. All right, well, we're going to go on to a new section where we apply all this information we just gained to solve some inequalities.